Okay, so test is tomorrow. And really, the hardest thing about this, it's not that we're doing a bunch of different stuff. It's really the same thing over and over again. You get your z, and then you get your probability from your table. I need to see your study guide. Okay. The difference is sometimes we're just talking about the variable x. Sometimes we're talking about x bar, and sometimes we're talking about p hat. So that's really what you have to watch on these, is our different variables and how we handle those. So just as a refresher, if we're talking about x, that's just our normal value. So then the mean and standard deviation is what's given in a problem. But x bar and p hat are a little bit different. In those, you are taking a group, you're taking a sample, and then looking at the mean or the proportion for that sample. And so when you're talking about those, we have certain criteria. Make sure you guys know this, so this might be a helpful thing to jot down. When we are talking about x bar, what criteria do we have to meet? Right. Either the original data has to be normal, or n is greater than 30. Okay, so when I ask you to check your criteria, I'm expecting you to say, oh, the original data was normal, we're good. Or, oh, sample is bigger than 30, we're good. Then the mean and standard deviation, those are straight off your formula sheet. So if you don't remember, you can look at it. When we're talking about our mean, that was under chapter 8, the first bullet. It tells us the mean for x bar is just the normal mean. Standard deviation for x bar is just your normal standard deviation divided by the square root of n. When we're talking about x, we just use the mean and standard deviation given in the problem. We don't have to do anything else. We don't have to check special criteria. We're just working the problem as given. When we are dealing with p hat, we have more criteria on this one. What do you have to check?
It has to be less than 5% of the population.
The sample has to be less than 5% of the total population, and n times p times 1 minus p has to be greater than or equal to 10. So anytime I say describe the sampling distribution, I'm asking you verify your criteria, mean and standard deviation. If you don't write down your criteria, I'm going to assume you don't know what they are, and you're going to lose credit. If you just say the criteria are good, that's not enough. I need to know that you realize what they are. Then the mean and standard deviation for those are given on your formula sheet. So that was chapter 8, the first bullet in the second column. The mean for p hat was just rp. Standard deviation is the square root of p times 1 minus p over n. So if you don't look over anything else before tomorrow, I would look at this so that you know what variable, what criteria goes with which variable. Then after that, it's all a matter of finding your z-score and getting your probability from your table. Okay, problem number 1. That was the only one that was a little bit different because it wasn't talking about a normal distribution. This was uniform. A uniform distribution is when everything has the same probability. So when you're drawing this, you should kind of make some effort to put it on a decent scale. It doesn't have to be anything too fancy, but this one is starting at 63 and going until 90. So I'm just going to do a little break in my graph. I'm going to say this is 60 so if you don't have anything on your x-axis, you need something. And the thing with the uniform is the probability is always the same. So at 63, whatever our probability is, that is the same all the way through until 90. So what happens is you end up with a rectangle. What we struggled with was knowing what goes up here. What's my probability?
127.
Right. So basically, you know, this is a rectangle, right? And a rectangle area is length times width. The area, since that's probability, is 1. The length, 90 minus 63, is 27. So that height has to be 1 over 27. Do you have your study guide? Let's see. Yeah, right?
Yeah.
Do you have the pass?
No, this is what should be.
All right. So part B, I want the probability that a random day has a temperature exceeding 68. So exceeding 68 is starting at 68 and going all the way to 90. So if you do 90 minus 68, you get 22. So area of a rectangle is length times width. So the length is 22. The width or the height is 1 over 27. You get 22 over 27 or 0.8148. Part C, probability is between 70 and 77. So if we subtract those, that's a width of 7. So length times width, we get 7 over 27, 0.2593. Is that okay with everybody? And again, the only time that works is for the uniform distribution because everything has the exact same probability. That's what creates that rectangle. Number 5. All right, and if we have any questions that pop up that you didn't ask, just feel free to let me know. This one wants z.034. So you have to know what that notation is. That's our z alpha. So you have a normal distribution. In z alpha, that number is the area to the right. So 0.34 is to the right. So would it make sense to draw my line all the way down here and shade all this? No. 34%, so definitely less than half. Okay. So we have to find the z value. Okay, this 34% is the area in that. When you look at your table, if you flip to your normal table, it shows you that it's giving you area to the left. So if we do 1 minus 0.34, that is 0.66. So what you're doing is going inside your table the closest we can get to 0.66. And what does that give us? What's the closest we can get? Yep. So if we look, 0.6591 is the closest, and so that is when your z is 0.41. Everybody see that on your table? Okay. Next one. Okay, we didn't really, you guys didn't ask about 6, 7, or 8, but you'll notice if we glance at those today, let's at least mention this. So in number 6, we have the average score with 20.8, standard deviation of 4.6. Part A, find the probability that a score is at least 25. Okay, does it mention anything about a sample in here? No, no mention of a sample mean, a sample proportion. This is just your normal stuff. So you're just finding the probability that X is at least or greater than or equal to 25. So then you convert that into a Z. The mean standard deviation we're given in the problem, so you're just using that mean and standard deviation for your calculation. When you look at problem 7, we're talking about the weather. We want to find the probability that next year it's more than 50. Again, it doesn't say anything about a sample. It doesn't mention a sample mean or a sample proportion. So we're not talking about X bar or P hat. We are just looking at one particular value. So our variable here is just X. So we turn it into our Z and go from there. Same thing with number 8. We have the charge life of a battery, normally distributed, mean standard deviation. We want the probability that a battery lasts more than 100 minutes. So not a sample, just one particular battery. Okay? Does that make sense to everyone? So let's go ahead and go to our next question. Number 9. I'm going to go ahead and talk about A as well as C, since we were asked about both of those. So we have a simple random sample of size n equals 36. So I have a sample. Then we are describing the distribution of X bar. So for X bar, what was our criteria?
Greater than 30.
Mhm. So if we look at this one, it didn't tell me it was normal, but my n was bigger than 30. So that means it is approximately normal. Alright. Then we need our mean and standard deviation. So from the formula sheet, mean for X bar is the same as our sample mean, which is 64. Standard deviation for X bar from our formula sheet is the population standard deviation divided by the square root of n, and we get 3. So when I ask you to describe it, those are the 3 things I'm looking for: criteria, mean, standard deviation. So then on part C, we want the probability that X bar is greater than or equal to 68.7. Alright, so what do we do?
68.7 minus 64 over 3.
Okay, we need a Z value. So Z from our formula sheet is our value minus the mean, since we're dealing with X bar, the mean for X bar, divided by the standard deviation for X bar. And so if we do that, we get 1.57. So we are finding the probability that Z is greater than or equal to 1.57. Our table gives us less than. So to find greater than, what do we do? So 1.57 is 0.9418. We get 0.0582. Questions? Problem 10. approximately 22.4% of adults are smokers. A random sample of 300 is obtained. Describe the sampling distribution of p hat. And I knew that this was going to be a p hat before I even said that because we have a sample. So we're either going to be dealing with x bars or p hats. And when I'm talking about a percent or a proportion, we know that's always p hat. So, criteria. We know the sample has to be less than 5% of the entire population. Did I tell you the entire population? No. But would 300 be less than 5% of the adult American population? Second one, N, which was 300, times P, which was 0.224, times 1 minus P, gives us what? $52.1472. So that is greater than 10. So we're all good. Our criteria are met, which means we can assume this is normal and we can go ahead and keep working our problem. So then we need our mean and standard deviation for p hat. Mean for p hat is just our p value, which is 0.224. Standard deviation for p hat is what?
Times 1 minus p over.
P 1 minus p over n. Make sure you're keeping more than just a couple decimal places on this. I usually do 4. That is all under the square root, so you get 0.0241. So that's part A. Part B. In a random sample of 300, what is the probability that at least 50 are smokers? Okay, 50, that's just a certain number, but our variable here is p hat. So we need to find the p hat. So p hat from our formula sheet, x over n. So 50 out of 300 gives us 1667. We wanted the probability that at least, so greater than or equal to this. What do we do now? So our value minus the mean divided by the standard deviation. Just like keeping one more decimal place on your standard deviation could change your answer slightly, so just make sure you're showing me all of your work along the way. So if you rounded something a little bit different than me, I know how you got your answer. And so this gives us a negative 2.38. So we need the probability that z is greater than negative 2.38. Table gives us less than, so we have to do 1 minus. And then if we look that up, we get 0.0087. So that gives us 0.991. So part C wants to know, would it be unusual if 18% or less were smokers? So, 18%, that's a proportion. What do we need to find here? We're doing less than. Z. So we did a negative 1.83. So less than is what our table gives us. So we look that up. And we get 0.0336. So the question was, would that be unusual? What does it take to be unusual? Mhm. Okay. So what does that mean if you get something that's unusual? Might be we have a bad sample for some reason, or it may be that the value has changed, that it's really not the same as our original proportion anymore. Okay. Questions on problem 10? So hopefully we're realizing this is all very, very repetitive. You're really the only thing you've got to watch is, am I just giving you a value where you jump in and get your z-score, or am I giving you an x-bar or p-hat where you have to find your mean and standard deviation before you can do that? Alright. Okay, so you guys were good on 13? Number 13. We had, you guys were okay with A and B, we just need to look at part C, the confidence interval. Alright, so,
You missed the first one, not the second.
oh, on your interval, you missed the first number in your interval, is that what you're
Probably,
saying?
yeah, like, you missed the first one, but we did miss the second.
Okay, let's take a look and see what happened. So with these, the other thing we need to watch, so kind of back to our list of things to remember, when we are talking about the x-bar and the p-hat, we can do confidence intervals, right? But the difference is one of them uses z and one uses t when you're doing your confidence interval. If you forget which is which, you can always go back on your formula sheet and it tells you, the first bullet, if you're building a confidence interval around p-hat, you're using the z values. So this one uses z alpha over 2 for the confidence interval. But if you go down to that next bullet, when you're building a variable or a confidence interval about the mean, that's when you use the t for a confidence interval. Alright, so problem 13, we are building a confidence interval for p-hat. So we are using the z alpha over 2. And of course we have that formula right there in front of us that tells us it's p-hat plus or minus z alpha over 2 times the square root of p-hat and minus p-hat over n. So my p-hat in this problem, you found it on part A. You did 768 out of 1024, so you got 0.75. Plus or minus z alpha over 2. Okay, some of these are given to you on your formula sheet, but not all, so let's make sure we know how to find this. We are building a 99% confidence interval. So that means 99% of the data falls in the middle. So I have 1% to split between the two ends, so each one would be 0.005. So if I'm trying to find my z, what am I going to look up on my table?
0.005.
That means there's 0.005 to the right, so to the left is 0.995. So you are looking inside your table, finding the closest to 0.995 that we can get. And so if we look, we have 0.9949 and 0.9951, so be right in the middle of those. So that's 2.575. This one is also given to us at the bottom of our little table. It does tell us the 99%, so we see where that came from. So 2.575 square root 0.75, 1 minus 0.75, divided by n, which is 1024. So let's put it in our calculator. So our confidence interval, we're going to start with the smaller one, so you do 0.75 minus 2.575 square root . And once you have that one, if you just do second enter, you can bring it back up and change it to a plus. And so we get that confidence interval. Everyone get it? Okay. I didn't say that you had to work it out by hand. So the other option is to use the calculator. Okay. So what do we go to on our calculator?
Stats test. This one will be a.
You go to stats, test, and then you go all the way down to letter A. This is a 1 proportion z interval. Everybody do that with me. So let's make sure we know how. So on the test, unless I say to do it by hand, you would be welcome to do hand or calculator. So then, if we go into that, first thing it asked us was the x value. So if we look, our x was the 768, our n was the 1024, confidence level is 0.99. And so if we calculate, we get 0.71514 and 0.78486. Why is it not a perfect match? You know, when we are looking at ours, we have some rounding error when we do them by hand, which again is why it is so important for you to tell me, if you're working it by hand, show me all the numbers you're plugging in. If you're doing it on the calculator, tell me you did it on the calculator so I can double check that.
On the test, do you want us to do like at least one by hand?
I will, if I want it by hand, I will state that it has to be by hand. If I don't, then you can do whichever. But yes, I would make sure that I knew how to do it by hand, just in case. Other questions? Number 14. A school administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size should be obtained? So as soon as I see that, I'm going to my formula sheet. Under chapter 9, the second column where it says sample size, and it tells me all the things about sample size. If she wishes the estimate to be within 2.5 percentage points with 94% confidence. Okay, so part A, a pilot study indicates that the percentage is 34%. So that is when we have a prior estimate. So that is the first formula. So n equals the p hat 1 minus p hat z alpha over 2 divided by the error squared. Alright, so now we have to find all these things. Z alpha over 2, is that one given on our table? No, we're looking at 94%, and that is not one that we can just look up. So we have to think through that. So if we're 94% confident, so 94% is in the middle, how much is on each side?
103.
So our table gives us to the left, so you are looking inside the table as close to 0.97 as you can get. That would be 0.9699. So 1.88. Okay. Our p hat that we're using is the prior estimate, which it said was 0.34. The alpha over 2 we just looked up. What is my error? You said within 2.5%, so 0.025. So plug this in our calculator. Okay, can we have a partial person? Regardless of what that decimal is, you always round up. So even if it were 1,268.001, that means 1,268 people would not be enough, so you have to go up. So we need a sample size of 1,269 here. Part B says if we don't use the prior estimate. So if you go back to your formula sheet, we're looking at that sample size bullet. The first formula is when we have a prior estimate. The second one is when we don't. So we have 0.025. Z alpha over 2 is the same one we already found. Error is the same as what we already had. Sorry, I wrote that down wrong. It should be 0.25, shouldn't it? Did I write that down wrong?
Yeah, it is 125.
So we get 1,413.76, which means the sample must be 1,414. Questions on that? Let's look at number 7. So a survey asking 40 Americans how many books they read per year found the mean was 13.4, standard deviation 16.6. We need a 99% confidence interval. So we are talking about X bar. When you're looking at your formula sheet, the confidence interval for X bar okay, so our sample mean was 13.4. Okay, T alpha over 2. We need to talk about how to use that T table. Degrees of freedom is what here? N minus 1. So we had 40, so N minus 1 will be 39. And then we need a 99% confidence interval. So 99% in the middle. So how much do we have for the two ends? right, 1% split in half, so 0.005. So we go to the 0.005 column down to 39 degrees of freedom, and we get 2.708. Everybody see that? Standard deviation was given in the problem, 16.6, divided by the square root of 40. So go to our calculator, 13.4 minus 13.4. And then if you do second enter, you can bring it back up and do the plus. So that gives us the upper and lower bounds. If you want to do this one on your calculator, yes.
I missed the part on degrees of freedom. So how do we, I know how we get our degrees of freedom, but on the table, how do we find the upper numbers?
That's our probability. So it was a 99%
Oh, okay.
confidence interval. So you have to take that 1% left over, split it in two for the two ends, so the 0.005.
Got it, thank you.
You're welcome. Where should we go to on our calculator for this?
18.
Number 8 T interval. So ours is based off stats. When would you do the data? If it gave us like a table of values that we put into the L1. So our X bar, the mean 13.4, standard deviation was 16.6. My sample size was 40. We were doing 99% confident. And we get the same thing. Possible difference on the final decimal place, but as long as I know where it came from, that's fine. Okay. Are there any that we did not go over that you would like to? A confidence interval. So let's say this is confidence interval. For P hat, and my sample size was 320. I want you to find the point estimate for the population proportion. What does that mean? How do we find our P hat from this? Right. You have a confidence interval from here to here. P hat is in the middle. So I get 0.46875. Okay. What if I asked you for the margin of error? How do we get it?
Minus the lower.
Okay. what if I asked you for X?
Multiply that by n.
We know p hat equals x over n. So we have the p hat. Our n was 320.